Pressure instrumentation design and selection for an oil well. When designing and selecting pressure instruments for an oil well, several critical factors must be considered to ensure accurate and reliable operation. Here are detailed explanations of the key considerations, followed by 4 specific examples of pressure instrumentation design and selection. Key considerations. 1. Accuracy. Measurement range. Ensure the instrument's measurement range covers the expected pressure variations in the well. Precision. Select instruments with high precision to detect small pressure changes, which is crucial for monitoring and controlling well operations. Temperature compensation. Consider instruments with built-in temperature compensation to maintain accuracy across varying temperatures. 2. Material selection for sour service. Corrosion resistance. For sour service, H2S environments, materials must resist sulfide stress cracking and corrosion. Common materials include Inconel, Monel, Hastalloy, and duplex stainless steel. NACE MR175's ISO 15156 compliance. Ensure materials comply with these standards for use in H2S containing environments. 3. Installation considerations. Location. Proper placement is critical to avoid vibrations, extreme temperatures, and ensure accessibility for maintenance. Mounting. Choose suitable mounting methods, e.g. direct mount, remote mount, based on the well's layout and environmental conditions. Protection. Use protective housings or enclosures to shield instruments from physical damage and harsh environmental conditions. 4. Other criteria. Redundancy. Implement redundant pressure measurement points for critical applications to enhance reliability. Signal output. Ensure compatibility with control systems, e.g. 420 mA HART, for seamless integration and data communication. Hazardous area certification. Select instruments certified for use in potentially explosive environments, e.g. ATEX IEC-EX. Examples of pressure instrumentation design and selection. 1. Example 1. Wellhead pressure transmitter for sour service. Instrument type, differential pressure transmitter. Accuracy, 0.1% of full scale, Inconel 625 for wetted parts to resist sulfide stress cracking. Installation, directly mounted on the wellhead with a remote seal to isolate the sensor from high temperatures. Other criteria, HART communication protocol, ATEX certification for explosive environments. Example 2, downhole pressure gauge, instrument type, quartz pressure gauge, accuracy, 0.01% of reading. Material, Hastalloy C276 for extreme corrosion resistance. Installation, integrated into the downhole tool string with cable connection to surface readout. Other criteria, high pressure rating up to 20,000 psi, NACE MR0175 compliance 3. Example 3, annulus pressure monitoring system. Instrument type, subsea pressure transmitter, accuracy, 0.2% of full scale. Material, duplex stainless steel for enhanced mechanical strength and corrosion resistance. Installation, subsea installation with protective enclosure and hydraulic tubing connection to the well annulus. Other criteria, 4 to 20 mA output, subsea connector with high IP rating, remote monitoring capability. For example 4, surface pressure sensor for hydraulic fracturing. Instrument type, piezoelectric pressure sensor. Accuracy, applying 0.25% of full scale. Material, Monel K500 for sour gas resistance. Installation, surface installation on the fracturing manifold with quick connect fittings for ease of installation and removal. Other criteria, real-time data transmission, explosion-proof housing, high-frequency response to capture transient pressure spikes. Detailed explanation for each example. Example 1, wellhead pressure transmitter for sour service. Design. A differential pressure transmitter is ideal for measuring pressure differences across wellhead equipment. The use of Inconel 625 ensures the transmitter withstands the corrosive nature of sour gas. Selection. The transmitter's accuracy of +0.1% ensures precise monitoring of wellhead pressure, crucial for safe and efficient well operations. Direct mounting with a remote seal protects the sensor from high temperatures and harsh conditions. Example 2. Downhole pressure gauge. Design. Quartz pressure gauges are known for their high accuracy and stability, making them suitable for downhole applications. Hastalloy C276 is selected for its excellent resistance to corrosion in high temperature and high pressure environments. Selection. The gauge's accuracy of 0.01% allows for detailed pressure profiling and reservoir analysis. Its integration into the downhole tool string enables continuous monitoring during drilling and production. Example 3. Annulus Pressure Monitoring System. Design. Subsea pressure transmitters are designed to operate in extreme underwater conditions. Duplex stainless steel provides the necessary durability and corrosion resistance. Selection. The transmitter's accuracy of 0.2% ensures reliable monitoring of annulus pressure, which is vital for maintaining well integrity. The subsea installation and protective enclosure ensure long-term operation without maintenance. Example 4. Surface pressure sensor for hydraulic fracturing. Design. Piezoelectric sensors are suitable for capturing dynamic pressure changes during hydraulic fracturing. Monel K500 is chosen for its robustness in sour service environments. The stout selection. The sensor's accuracy of 0.25% and high-frequency response are essential for monitoring pressure spikes during fracturing. The quick connect fittings and explosion-proof housing facilitate easy and safe installation on the fracturing manifold. By considering these factors and selecting the appropriate pressure instruments, oil well operations can achieve high levels of accuracy, reliability, and safety, ensuring efficient and trouble-free production. Detailed considerations for monitoring and controlling downhole pressure. Monitoring and controlling downhole pressure involves several critical considerations related to operations, maintenance, and control. Here are detailed explanations with specific practical examples of potential issues and strategies to overcome them. Operations. 1. Instrumentation selection. Accuracy and precision. Instruments with high accuracy and precision are crucial for detecting small pressure changes. Range. Ensure instruments can handle the expected pressure range, including transient pressures during drilling, completion, and production. Durability. Instruments must withstand harsh downhole conditions, including high pressures, temperatures, and corrosive environments. Example issue 1. Instrument failure due to high temperature and pressure. Problem. Standard pressure gauges failing at high temperatures and pressures. Solution. Use quartz pressure gauges designed for high temperature and high pressure environments. These gauges provide reliable performance and accurate measurements under extreme conditions. 2. Real-time data acquisition. Data transmission. Implement reliable data transmission systems to relay real-time pressure data to the surface. Power supply. Ensure continuous power supply for downhole instruments, potentially using battery packs or downhole power generation systems. Example issue 2. Data transmission interruption. Problem. Interruption in data transmission due to cable damage or signal interference. Solution. Use high-quality, robust cables with protective sheathing and redundancy in data transmission paths. Employ wireless telemetry systems where feasible to avoid cable issues. Maintenance. 1. Scheduled maintenance. Calibration. Regularly calibrate downhole pressure instruments to maintain accuracy. Inspection. Conduct periodic inspections of downhole equipment to detect and address wear and tear. Example issue 3. Calibration drift. Problem. Pressure sensors drifting out of calibration over time. Solution. Implement a routine calibration schedule and use calibration devices capable of being deployed downhole to recalibrate instruments in situ. 2. Replacement and upgrades. Modular design. Use modular instrument designs that allow for easy replacement and upgrades without extensive downtime. Material upgrades. Upgrade to materials that better resist downhole conditions, such as improved corrosion-resistant alloys. Example issue 4. Corrosion of downhole instruments. Problem. Corrosion of pressure sensors, leading to inaccurate readings and potential failure. Solution. Replace sensors with models made from high-grade corrosion-resistant materials like Inconel or Hastalloy. Implement chemical treatment programs to reduce corrosive elements in the well. Control aspects. 1. Automated control systems. Integration. Integrate downhole pressure data with automated control systems to adjust well parameters in real time. Algorithms. Use advanced control algorithms to predict and respond to pressure changes promptly. Example issue 5. Overpressure events during production. Problem: overpressure events leading to equipment damage and safety risks. Solution: implement automated control systems that can quickly adjust choke valves or alter flow rates to maintain safe pressure levels. Use predictive analytics to anticipate pressure surges and take preemptive actions. 2. Redundancy and safety systems. Fail-safes. Design systems with fail-safes that activate in the event of a sensor failure or data loss. Emergency shutdown systems, ESD, integrate ESD systems that can automatically shut down operations if dangerous pressure levels are detected. Example Issue 6. Sensor failure during critical operations. Problem: failure of a critical pressure sensor during operations, leading to loss of monitoring capability. Solution: implement redundant sensors at critical points to ensure continuous monitoring. Configure the control system to default to safe operational parameters if a sensor fails, and trigger alarms for immediate investigation and remediation. Practical examples of issues and solutions. 1. Issue: instrument failure due to high temperature and pressure. Problem: standard pressure gauges fail at high temperatures and pressures. Solution: use quartz pressure gauges that are specifically designed for high temperature and high pressure environments, providing reliable performance and accurate measurements under extreme conditions. 2. Issue: data transmission interruption. Problem: interruption in data transmission due to cable damage or signal interference. Solution: use high-quality, robust cables with protective sheathing and redundancy in data transmission paths. Employ wireless telemetry systems where feasible to avoid cable issues. 3. Issue: calibration drift. Problem: pressure sensors drifting out of calibration over time. Solution: implement a routine calibration schedule and use calibration devices capable of being deployed downhole to recalibrate instruments in situ. 4. Issue: corrosion of downhole instruments. Problem: corrosion of pressure sensors leading to inaccurate readings and potential failure. Solution: replace sensors with models made from high-grade corrosion-resistant materials like Inconel or Hastalloy. Implement chemical treatment programs to reduce corrosive elements in the well. 5. Issue: overpressure events during production. Problem: overpressure events leading to equipment damage and safety risks. Solution: implement automated control systems that can quickly adjust choke valves or alter flow rates to maintain safe pressure levels. Use predictive analytics to anticipate pressure surges and take preemptive actions. By addressing these considerations and implementing the suggested solutions, oil well operations can achieve more reliable and accurate downhole pressure monitoring and control, enhancing overall safety and efficiency.